So today I'll be teaching the direct comparison test, and in order for it to work, you need two series. An A of n and B of n. In order for this to work, A of n and B of n both need to be greater than or equal to 0. And A of n needs to be less than B of n. Once you have those conditions met, you need, in order to tell whether it converges or diverges, you need two terms. If B of n converges, then A of n converges as well. And then if A of n diverges, then B of n will also diverge as well. When solving direct comparison tests, you need to make sure that you check the series after you can determine whether it converges or diverges, just to make sure. And now we'll do an example. This example of n over n squared minus 1, the A of n would be the original series, which is n over n squared minus 1, while B of n would be a simplified version, which would just be n over n squared, or 1 over n. Since you can see that B of n diverges by the p-series test, because p equals 1, then you can also tell that A of n diverges, since A of n is less than B of n in this instance. I don't know if that worked very well.
Today we're going to talk about the limit comparison test. This is a test that is especially useful for messy algebraic functions or series. An example of a messy series would be, let me just write one out for you. N to the 17 minus 14 n to the 5th plus 5 n to the 4th minus 58 n to the 3rd plus n squared minus 496 n plus 2 over n to the, I'm going to make that 18, n to the 9th plus 14n squared. It's pretty messy, huh? Alright, so you're wondering, how do we solve that? Limit comparison test, that's where it comes in. Alright, so the requirements for limit comparison test. This is going to be your A sub n, right there. And now your B sub n is going to be a p series of that. So you're going to take the greatest power on top and the greatest power on bottom. So your B sub n would equal n to the 18th over n to the 9th. Alright? Now, this is limit comparison test. The next requirement, or the first requirement, is that B sub n and A sub n are greater than 0. This we have. The next one is that A sub n over B sub n is finite and positive. Alright, so when you put A sub n, n to the 18th minus 14 n to the 5th plus 5 n to the 4th minus 58 n to the 3rd plus n squared minus 496 n plus 2 over n to the 9th plus 14n squared over n to the 18th over n to the 9th. That turns into, I really don't want to write this out again, you can flip and multiply by the reciprocal, and now that becomes n to the 9th over n to the 18th. And can you pause it real quick? We good? Alright, now to make this a little bit easier, we can recognize that this is just 1 over n squared. So change that to that, multiply across, and you get this function, the top one, so n to the 18th minus 14n to the 5th, plus 5n to the 4th, minus 58 n cubed plus n squared, minus 496 n plus 2, over n to the 18th plus 14n to the 4th. Alright, now what you have here is you can do the nth term test. And n to the 18th, that is 1. Okay, that is both finite and positive, so the limit comparison test works. Now what are you trying to prove with the limit comparison test? You're trying to prove convergence or divergence. So, going back to b sub n over 18 over n over 9 equals n squared. N squared diverges. So the limit comparison test is saying if it's finite and positive when a sub n over b sub n, if it is, then if b sub n converges or diverges, then a sub n will also do that. So b sub n in this instance diverged. So when you do this, it equals 1, finite and positive, so a sub n diverges as well. Boom.